Okay, Bismillah. Okay, we will start inshallah, yeah. Now this is actually paper, I will write it down. This is actually 0620. This is actually, which paper is this? Just 1 second. Okay, this is October, November 2019. Just 1 second. And it's actually a paper 4. Paper 4, yeah? Paper 4. And this question is question number 3. There you go. All right. Now, it is actually asking about ammonia. Ammonia is an important chemical. Part A, part A, ammonia is manufactured by the Haber process. Yes, Haber process is a very important process, and some of the key point, yeah. For example, the condition and how Haber process is done, you do need to memorize. So take the opportunity to do the memorization now, yeah. So it says here, ammonia is manufactured by the Haber process. So I do hope after this, you are good at Haber process. Yeah, inshallah. The reaction is reversible. What is the sign for a reversible reaction? So this is so easy. I think they're just giving you, a free marks for you here. So reversible is just half arrow forward, half arrow backward. It's not that easy for me to write on the screen. So that is actually for 1 mark. So that is reversible. Now let's have a look at part 2. State the essential condition. This one you have to memorize for the manufacture of ammonia by the Haber process. Starting from hydrogen and nitrogen. What do you need to include? Include a chemical equation to show the reaction which occur. Unfortunately, you have to memorize. Memorize what? Okay. I think in terms of the equation, no need to memorize because you know what is actually the reactant. Reactant is nitrogen and hydrogen. So you just write down nitrogen, hydrogen. So let's say, so we were to do this again. All right, so all you need to do is, you know what is the reactant? Nitrogen. Nitrogen in the form of a molecule. So N2 is actually a gas. Okay. Now, react with hydrogen, H2. Also, hydrogen cannot exist on its own. A gas as well. What did you get? You will get ammonia. What's the symbol for ammonia? NH3. Now, after that, you do need to balance this chemical equation. Okay, how to balance? Both the left and the right must be the same number. Now, I have hydrogen here is actually 2. Hydrogen here is actually 3. But I can see also nitrogen here is actually 2. And nitrogen in my ammonia is actually 1. So I have no choice but to put number 2 here. So what happened? I got 2 nitrogen here. And then automatically you have to multiply your hydrogen by 2. So 3 hydrogen here multiplied by 2 will be 6. So I have no choice but to put 3. Yeah, number 3 there. So in other words, I have 1 mole of nitrogen reacts with 3 mole of hydrogen, producing 2 mole of ammonia. And this is also gas. So in other words, if I were to do this question, I just put down the equation. So what are the conditions? you can say the condition required. Oh, the condition, just put condition here. Condition needed, okay, at high temperature. What are the things you have to memorize? The temperature itself. Between 330 degrees Celsius to 500 degrees Celsius. You have to remember this. Okay? While doing the lesson with me, I want you to start memorizing also. You have no choice actually. This is the temperature, high temperature, 330 degrees C and 500 degrees C. Now, what about the pressure? Also, okay, high pressure. So what's the pressure? 100 to 300 atm. What else? You do need a catalyst. Okay, you do need a catalyst. And what is actually the catalyst? Iron. So what are the conditions that you have to remember? Only 3 conditions. What is actually the temperature? What is the pressure? And what is actually the catalyst? Can you start memorize it now, Gina and Fatima? Yes? Start to put inside the, okay, storage in your mind. Haber process, the condition, 330 degrees C, that's the temperature, yeah? Until 500 degrees C. I want you to start putting that in your mind. What about pressure? 100 to 300 atm. What about the catalyst? Iron catalyst. Okay. Then you can say that the reaction is exothermic. Okay. So 5 marks. If you give the equation, 1 mark. If you give all of these 3 conditions, 1 mark each will be 4 marks. And then you can say the reaction is exothermic, 5 marks. You see how easy to answer your chemistry. You don't need to do a long essay. You can give your answer in a point form. It's okay. Because why? Because in chemistry, what is most important is the key word. Yeah, is the key factor. So this type of question, you have no choice because this is directly from the book. We have no choice but to memorize. Okay, next question. Also, this is a fact as well. Name one raw material which is a source for the hydrogen used in Haber process. One raw material, a source for hydrogen use in the Haber process. In other words, where do you get the hydrogen from? We have a lot of, you can get the hydrogen from water, yeah. They said name, so just name it. Or you can get it from natural gas, or you can get it from methane. So any one of the answer. So this is kind of easy. So anything, yeah, the source for hydrogen, either we got it from water because water is H2O, natural gas, because any natural gas, you can just say natural gas without even mentioning what the gas is. If you were to mention methane, so natural gas are propane, methane, or you can mention it specifically, your methane. Yeah? Okay, that is for 1 mark. Unless? All right. Next question, part B. Ammonia is a base and reacts with sulfuric acid to form the salt ammonium sulfate. What is meant by the term base? I've seen a lot of questions like this in the past paper. So either they can ask you what is meant by the term base or alkali. Okay. So you can answer in terms of, just 1 second. Teaching. I'm teaching. Okay. Okay. You can answer regarding using what is it? Proton donor or a proton acceptor. This is one of the best answer. Yeah. When you want to explain the meaning of base alkali, talk about the proton. So a base is actually a proton acceptor. Proton acceptor. Just to go through this topic, sometimes they will ask you what is the meaning of an acid. Yeah, an acid is the opposite, proton donor. So I just want you to get yourself familiar with the definition of your acid and your base or alkali. So put it inside your mind that try to remember this. An acid is a proton donor, whereas base is a proton acceptor. Okay. Now, one of the reason why an acid is a proton donor is very easy to understand this concept. Now, remember, when we talk about acid, what is the most important ion that we talk about? An acid is the presence of the hydrogen ion. Hydrogen ion. Let's say you forgot about this, okay? I don't know. I don't know how to define acid or a base. Remember one thing. What is the thing that you do need, okay, in order for that something or that compound or whatever it is to become an acid? Is the presence of hydrogen ion. Okay. If that is the case, okay, there is a must. Okay, a must in an acid to have hydrogen ion. So in terms of definition, okay, this why is this hydrogen ion is so important? Because this hydrogen ion is the one will react in the reaction of your acid. So if that is the case, your acid is providing this hydrogen ion when it reacts with whatever it is. Yeah. So that's why we call it a proton donor. That's how you can actually try to remember also. If that is the case, your base or alkali is the opposite. In order to define your base or alkali, just define the opposite of the definition of your acid. If acid is a proton donor, a base would be a proton acceptor. As simple as that. Gina, Fatima, is that all right?
Yes.
Okay. I do hope after this you can remember this, yeah, because I've seen a lot of this Either they will ask you the definition of acid, or they will ask you the definition, for this case, definition of a base. It's a very easy concept. And please do not go around saying acid, blah, blah, blah. No, 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 no. Just talk about the proton. What is the proton? The hydrogen ion. Khalas. Right, next question. Name the industrial process used to make sulfuric acid. Okay, to make ammonia is the Haber process. What about making sulfuric acid? This is very common also, and you have to remember this as well. Anybody wants to answer? Gina? Fatima? What's the name of this process? Contact process. It's very easy. Haber and contact. There you go. If you forgot about it, you have to remember now, yeah? Manufacture of sulfuric acid is called contact process. Okay. So what is the thing that you have to remember today? The name also. Sometimes they will ask you, what is name the industrial process used to make ammonia? So your answer is Haber process. Name the industrial process used to make to make sulfuric acid. Contact process. Two process that you're learning today and you have to remember. Okay? Remember the name. What is the name? Now let's have a look at the next question. Write a chemical equation for the reaction between ammonia and sulfuric acid. So we want to write a chemical equation for the reaction between ammonia and sulfuric acid. Okay, even though you don't know what's going on, it's very easy in chemistry. Reaction between what? Ammonia, sulfuric acid. Okay, give the symbol of ammonia, NH3. No problem. What's the symbol of sulfuric acid? H2SO4. Now, when I'm typing, all of this number 2 and number 4 are the same level, but it should be subscript, yeah? It should be a bit below. I cannot type it like that. For this case, do they need the state? No, no need. So, halas, then don't give. Just the equation only. Okay, no problem. What is ammonia? Ammonia is actually an alkali or a base, okay? And then you got your sulfuric acid, which is an acid. So what will happen? Well, it's very easy. This is a sulfate. This is a sulfate, yeah? So this is ammonia. So ammonia will become ammonium, NH4. All right? And then what will happen to ammonia? Become ammonium. And this ammonium is NH plus, carrying the charge of NH4 plus, yeah? And what about your from the acid, you will have the sulfate, SO4 2 minus. There you go. If we were to combine them together, they will become ammonium sulfate. So you can see the 2 minus and a 1 plus. So in other words, in order to become a 2 plus here, I do need how many? 2 ammonia. Okay, 2 ammonia. So since ammonia is NH4, we have to create a bracket. How many do we need? 2. Okay, halas. Then we just delete the charge. So it should be a neutral compound. Yeah. Now you can see that how your acid here is a proton donor, meaning it is providing your hydrogen. You see it? NH3. Where does the extra hydrogen coming from? From the acid. From here, you can see the concept. Acid is a proton donor. So in other words, from the acid, you got extra hydrogen for the ammonium. Yeah? And then you can see that the ammonia is actually a base. So it is accepting. So confirmed by the definition, proton acceptor. NH3 accept one more, becoming 4. NH4 is becoming an ion because your proton is actually a hydrogen ion. Yeah? So it carry a positive charge. Can it become NH5, NH6? No, it's only NH4. So you will get your product NH4 to SO4. That is actually ammonium sulfate. Ammonium sulfate. Okay. Do I need to balance this chemical equation? Yes, I do need to balance it. How to balance? We have to do trial and error. Okay, let's check the number. Use a pencil. In the exam, don't use pen, trial and error. Use a pencil. Check what? Okay, I'll teach you a shortcut way. We can actually get sulfate as a package. You can do so. One sulfate here, one sulfate here. No problem. Okay. And then afterward, the nitrogen, hydrogen, you do it separately, one by one. Okay, one by one. So how many hydrogen? 4 times 2, 8. 4 times 2, 8, yeah. So how many hydrogen here? You've got 3 here. And then we got 2 here. Oh, okay. Now let's have a look at nitrogen. I got how many here? 2 here. I got 1. Okay, that's why this is called trial and error because we just don't know. Maybe I just put here 2 here. Just for the sake of 2 nitrogen. When we saying try and error, definitely we don't know. Yeah, we don't know. First, we're just trying our luck. So that's why we have to look at both nitrogen and hydrogen. So I can see that 2 nitrogen, nitrogen here times 2. Okay, nitrogen is balanced. Okay, check the hydrogen again. 2 times 3, 6. 6 plus another 2, 8. Here, 4 times 2. Oh, okay, halas, it's balanced now. Then we get your pen, write it down. This is how you do it in the exam. Yeah, so we can write it down, number 2, in front of you. There you go. Now it's balanced. 2 marks for that. Any questions so far?
No.
Okay. I think we can do one more question and then we can stop here. Maybe part C. Yeah, we can do very quickly. I can explain very quickly, inshallah, because it's not that difficult actually. All right. When aqueous ammonia is added to iron 2 sulfate, a green precipitate is seen. This green precipitate turns red-brown at the surface. So we got what happened here. First, we have green precipitate, green. And then afterward, this green precipitate becoming brown. I don't have brown, so I just want to put a bit red here, red-brown at the surface. So the green becoming red-brown. Okay. Aqueous ammonia, if we were to draw the symbol of aqueous ammonia, is actually ammonium hydroxide, OH, NH4OH. Yeah, NH4OH, ammonium hydroxide is aqueous ammonia. I just want to highlight here, sometimes they say ammonium hydroxide, sometimes they say aqueous ammonia. And I wanted to say to you, aqueous ammonia is the same as ammonium hydroxide. They are of the same thing. So in other words, the symbol for aqueous ammonia is NH4OH. Although, I mean, we can answer this question very quickly, but I just want to do a bit of a theory here, yeah? Just for you to remember also. Right. aqueous iron 2 sulfate containing ferrum 2 plus. Yeah, ferrum 2. So containing ferrum. So ferrum 2 ion is actually green color. So I'm just going to put green color. This is green color. Okay. So in your iron 2 sulfate, what is the cation in the iron 2 sulfate? Ferrum. Okay. Is the ferrum 2 plus, Fe2 plus. How do I know this number? Number 2. You look at because this is a transition metal. Okay, I did a bit of a note here. If it's a ferrum 2, meaning it's iron 2. What is the symbol of the ion? Fe2 plus. What is the color of the ion? Is green. We have another ferrum because ferrum is a transition metal, which is ferrum 3. Ferrum 3, we can say ferrum 3 or iron 3. What is it in ferrum 3? If it's a compound, we have the ion of, okay, Fe3 plus. And this color is actually reddish brown. All right. Now from here, we will know how to answer this question. The first question is that name the green precipitate. Okay. So you got ferrum 2 sulfate reacts with ammonium hydroxide. It's very easy. In your chemistry, always changing partner, yeah? So let's say this is the hydroxide part. So what happened? The iron 2, okay, will take the hydroxide from the ammonium hydroxide. So the green precipitate is, okay, ferrum. They say name, yeah? So iron, the name will be iron 2 hydroxide. Don't give symbol because they ask for the name. There you go. Iron 2 hydroxide. Right. Suggest why the green precipitate turns red brown at the surface. 2 plus becoming 3 plus is very easy. Ferrum 2 plus, Fe2 plus ion is oxidized by oxygen at the surface. Okay, to ferrum 3 plus. That's it. For 2 marks. If you mention Fe2 plus to Fe3 plus, you get 1 mark. And then you mention about oxidized by oxygen, that would be the second mark. Okay. Next question. State what happened when an excess aqueous ammonia is added to the green precipitate. So add more of the, nothing happened. Why? Because, okay, you got the precipitate insoluble in excess. So you can say insoluble in excess, no change. Yeah, something like that. That deserves a 1 mark. Okay, Hanas. Alhamdulillah, yeah. So you learn a lot today. Now take the knowledge bit by bit. You don't have to rush. And what is your target? Your target is in A, definitely, inshallah, inshallah. If you try slowly and slowly, and you can tell your friend who is not here today, tell them to watch the video. Okay? Because this is actually something to benefit you. You got your seniors last time doing the same thing bit by bit, once a week only. What do they get for their IGCSE? An A for chemistry, alhamdulillah. So I would, hopefully that I can help you as well to get your desired A for your chemistry, inshallah, yeah? Okay. Stop recording.